Welcome back. This is the second lesson recording for IM1, October 30th, 2020. So we are continuing with the decimals exercise. So we are on card 7 now. The inside area calculations are gone. It's up to you now. Create the visual for the following product. So first we need to create x plus 9 as the length and x plus 11 as the width. So x plus 9, I need to make this longer to be x plus 9, because I have the x, I need the 9 to be longer, or the number to be longer. Now x, I have the x, but I need it to be not 1, but I need it to be 11. So here we go. So let's make it higher. There we go. So x plus 11 times x plus 9. Alright, so then I need to find the area. Okay, before they used to find it for us, but we need to do it ourselves. So how do I do this? The length for this rectangle is x, the width is x. So x times x is x squared. What about the length here is 9 and the x is unknown. So x is 9 times x, that's just 9x. So x, this length is x here because this length is x. So this is same as x times 11 is 11x here. What about this? We have 9 is the length here and the width is 11. So 9 times 11. 9 times 11 is 99. Okay, so then we just need to enter the total area of the rectangle. Look back on the previous card if you need to. Remember to combine like terms. So far we have what we have is x squared plus 9x plus 11x plus 99. Okay, now do you see any like terms here? Well, it's the 9x and 11x, right? So we can say that now 9x plus 11x is going to be 20x, but everything else is the same. So x squared plus 20x plus 99. That's my final answer. Okay, let's go to the next card. Alright, so now this is another card sort. So we need to, this time this is with variables. Okay, so we need to be looking at, if you cannot see very well, you can always click on it and it's going to get bigger for you. So x plus 8 multiplied by x plus 3. Okay, so x plus 8 multiplied by x plus 3. That makes it actually easier because we don't have to count those little grids. Alright, then what do we have here? Okay, again it's going to be x plus 8, that's the length, times x plus 8. So I'm looking for x plus 8 times x plus 8. Here we go. Alright, so then let's look at this one. Let's bring it out here. Let's bring those cards down so that it doesn't get messed up. Okay, so we have the length is x plus 9 and width is x plus 7. So x plus 9 and x plus 7 is this. So put them together, and then finally, what do we have here? X plus 6 and x plus 4. X plus 6 and x plus 4. Here we go. Okay. Alright, so now we need to do the more challenging part. We have the x times x. They all have the x times x, x times x, x times x. So that we're going to always have x squared. But we are going to have different values here. Okay, so here we are multiplying 9. This is 9 and this is 7. So 9 times x is 9x. So I can write it here as 9x. And this is 7. How do I know it's the 7 here? 7 times x is 7x. So I want the middle term to be 9x plus 7x is going to be 16x. So I want 16x, but what about the last squared? Last squared is going to be this is 7, this is 9 and 7, so 9 times 7 is 63. Okay, so I am looking for 16x and 63, so here we go. So I bring that over here. Okay, then what about this? I have 6 times x, so that's 6x, and this is 4 times x, so that's 4x, and 6 times 4 is 24. So combining 6x with 4x, we have x squared plus 6x plus 4x is going to give me 10x plus 24. So x squared plus 10x plus 24. Here we go. Alright, and then finally, what do we have here? X squared, x times x is x squared. This is 8 times x is 8x, and 8 times x is 8x again. 8 times 8 is 64. So now this time I have x squared plus 8x plus 8x is 16x plus 64. So it's this one. And so this one, the last one, has to be this. Okay, and you can certainly confirm it. Alright, then let's move on to the next card. Now this time we are asked to model this. So the length is 3x plus 5. We do have 3x here, but we want this to be not 1 but 5, so I need to change that to 5. And x plus 8. X plus 1, I don't want 1, I want it to be 8. Okay, so now we have x plus 8 multiplied by 3x plus 5. Okay, and the area is, what is the area? The area, this is the area as a product, and the area as a sum is going to be the sum of all these little rectangles, including, I need to make sure I combine the like terms. So I have 3x squared, and I have 5x plus 24x. How many x's do I have now? That's 29x. And then plus 40. And that's my final answer. And then last card before we go back is this. Now we need to model 6x plus 2 and 4x plus 5. Okay, so we need to make sure we have 1x. We don't want 1x. We want 6x. So with 2x, 3x, 4x, 5x, 6x plus 2. I need this to be 2. Okay, and the width is 4x. So I need this to be bigger. 4x, oops, 4x now, and plus 5. I need the number to be bigger too. Okay, so here we go. So 6x plus 2 is the length. 4x plus 5 is the width, and so to figure out the area I need to multiply 6x times 4x. Well, multiplying 6 times 4 is 24, and x times x is x squared. 2 times 4x is 2 times 4 is 8x, and 6x times 5 is 6 times 5 is 30, and we still have x to multiply, and then 2 times 5 is 10. Then after we're done, we need to combine like terms. And like terms, hopefully you are recognizing it always comes in the diagonal. Okay, so we have 24x squared and 8x plus 30x. So 8 plus 30 is 38. So it's going to be 38x plus 10. And that's what we have. Okay, great. So let's get back to the lesson slides and let's do some more vocabulary work. So when we're talking about what we're doing, we are going to be using some vocabulary terms. In fact, a term. What is a term? Term is a part of an expression separated by addition or subtraction sign. So when you see this expression, it's a mathematical expression or mathematical sentence, it's separated by plus, 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 right? So those are the ones that they are the separators. Okay, they're separating it. So that means, which are the terms? We have 3x to the power of 3, 10x to the power of 3, and 2x and 7. So we have 4 terms. 1, 2, 3, 4. Okay, what about this? How many terms do you have when you have negative 4x squared? Okay, do we have anything being separated by addition or subtraction? No. So that means the expression with one term. This only has one term. What about this? X squared minus 3. Okay, there is the negative sign, which could be interpreted as minus or subtract. So this is minus sign, so that means we have 2 terms. Great. So then what about coefficient, constant terms? Oops. Okay, coefficient is a number multiplier in front of the variable. In front of the variable, variable in each term. Okay, so when you have this 3x squared plus 10x squared plus 2x plus 7, you see there are some variables in front of there are some numbers in front of the variables, the 3 and the 10 and 2 and 7. So 3 is the coefficient of x cubed terms. X cubed term, 3 is the coefficient of this term, and 2 is the coefficient of the x term. Okay, I could also say 10 is the coefficient of x squared term. Now, another term that we did come across is constant term. Is a special type of term, only has numbers. Okay, so let me move my cursor. Okay, that works. Okay, only has numbers. So 7 is the constant term because it does not have any variables. We've talked about this before. And then finally, the like terms are terms with the same exponent on the variable. Same exponent on the variable. Like, so for example, 2x cubed and minus 4x cubed and x cubed are all like terms because they have not only the same variable, but they also have the same exponent. Okay, so because the exponent on x is all 3. However, 3x squared, 3x are not like terms because exponents on x are 2 and 1. So here x squared, the exponent is 2. Here for x, the exponent is 1. So these two are not like terms. Alright, so some more vocabulary. Polynomial. What's a polynomial? It's an expression with one or more terms. Remember the parts, where each term is a power term of the form real number x to the power of whole number. So that means if you have 4x squared minus 3x plus 6, okay, because we have each term has a power term. Okay, so we have x squared and x here. So this is polynomial with 3 terms, and this is a polynomial with 4 terms. But these are not polynomials. Why? Because we have a -1 exponent. Okay, when it's negative exponent, we do not it's a negative degree, so that it's not a polynomial. And the last one is 5 to the power of x. It's 5 to the power of x, so because the variable is as a exponent, so the exponent is not a whole number, so it is not a polynomial. Okay, great. So we are going to summarize what we learned. Our new fancy skill of multiplication. We have learned how to multiply 2 polynomials together with the help of area model. And so when we're multiplying numbers, we're multiplying first number with second number. You get 3 times 7 is equal to 21. With multiplying 2 polynomials, the length and the width, you multiply those together and you get the result.